Okay, now that we have graphed the sine, the cosine function, now we're going to graph our other basic trig function, which is the tangent function. And it looks very different compared to those other two graphs of the sine and cosine. Okay, so let's start like we did before. Let's start with the table of values here so we can see what the graph would look like. Let's again start with our unit circle. We have the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now remember how the tangent function is sine divided by cosine is equal to the tangent. Okay? So we're going to take the sine value, which is the y value, divided by the cosine to get the tangent. So 0 divided by 1 would give us 0. 1 divided by 0, let's write that out. 1 divided by 0, can we do that? No, we can't ever divide by 0, so that's going to give us undefined. Okay? And we have 0 divided by negative 1, which is, of course, 0. And again, a negative 1 divided by 0, we can't do that, and the 2 pi is back to where we started. Okay? So, like always, we've done with these, you've got to make sure that you label your axes. So let's go ahead and put that as pi, and this is 2 pi. And then we'll look at everything once we have it graphed and see how everything works with this compared to sine and cosine. Okay? So, change the color here. At 0 is 0. At pi halves, it's undefined. That's going to be a vertical asymptote because we can't be there at all. Okay, so it's got to be a vertical asymptote, and then at 0 again, and then another vertical asymptote, and at 0 again, and you can see that that pattern would just keep going. If it went backwards, it would go the same way. Oops. Let's make that a little bit straighter. Oops. Let's see here. There we go. Dotted line a little bit better there, and then the dot there. Okay? And what's going to happen there is, in between these graphs, and if you were to do these, let's first look at this. The period is pi. From an asymptote to an asymptote, this is what's going to be your period now. Okay, from your asymptote to your asymptote is your one period. Okay, it's got to do everything in between that because then it's going to repeat and then repeat and repeat. Okay, your domain, you can tell right here your domain looks much different than before. Before we could use everything for domain. Okay, but now we can use everything for the range. So your domain looks a little weird. What that's saying is it's all the numbers in between here, and then in between here, and in between there. Okay? And then your vertical asymptote, it follows that same pattern. Okay? But what happens here is, remember how our period, let's look right here. Our period is pi over b. So, just like it was, with sine and cosine is 2 pi over b, but with tangent is just pi over b. So pi divided by our b value is still that same place, so it'll just be 1, so that's our pi. Okay? So I know from asymptote to asymptote, it's going to be 1 full pi. It says the midpoint between the asymptote is your x-intercept. That's what we had right here. Halfway between this one and this one is your x-intercept. Okay? Now your amplitude is not really defined because your amplitude is how high and how low your graph goes. But remember, our amplitude, or our range, is saying here that it's going on forever. So what happens here, just let me just show it to you, and then I'll kind of explain it. Okay. Halfway between the asymptote and the starting point is going to be right around here, and it's going to be at the 1. And halfway between those is at your 1. So it's kind of like what the amplitude is. Kind of helps you with your stretch of this curve. Okay. But what our curve looks like now, our curve looks like something like this, where it goes real close to the asymptotes, but again, you know, it doesn't touch it, but the curve goes there. So the critical thing here for what I'm concerned with is these 3 points. So I can tell you, so I can see how far it's curving, because the graphs could end up, some of those curves could end up being really flat through there, looking like this. Okay, some of them could be looking really pretty, almost straight line, almost like this. Okay, and then all it does is just that pattern keeps on going over and over and again. Okay, and we'll look at several examples of this and see how this works, so you can get the hang of this one, like we did with sine and cosine. But that is how the tangent function works. Okay, and a couple things I want to point out here. Some of my curves aren't very pretty, but that's okay. Is that the starting value of tangent is always 0. Okay, halfway backwards and halfway forward is how much half of your period is that way and half of your period is that way. Do not go out a full period that way and do like we did with the sine and cosine. Okay, half of it goes back and half of it goes forward from that starting point. Okay, so now let's go look at an example for tangent. So let's look at example number 7, sketch graph of y equals tangent of x over 2. So again, I'm going to write that as y equals tangent of 1/2 x, just so I can easily tell that is my b value. So my period, I'm going to label everything like we've always done. Period is pi over b, so that's pi over 1/2, which if you divide that out, that comes out to be 2 pi. Okay. Your amplitude, remember there's no really amplitude now, but your stretch would not be anything different than the normal because it's just a 1 out in front. Okay, so tangent of 0 is 0. Now my period is 2 pi, so let's count, you can do it kind of any way you want to, but I'm just going to go ahead and do it as like pi, 2 pi, 3 pi, count my pi's going left and right. Get the idea there, and then go 1s going up and down just like we've always done. Okay, so tangent of 0 is 0. Now what I always do, I always take care of my amplitude, or my period, my asymptotes. That's the word I was looking for. Asymptotes. We want to take care of those first. So remember, 2 pi is my period, so I don't want to go over 2 pi and put another point there. I want to go over half that distance and put an asymptote, and go over half that distance going backwards and put an asymptote. Okay, that's where it does not exist. And so what we're going to do now is halfway between those is going to be your lowest. So we know that's going to be at a -1. Halfway between those is going to be that point right there. So it's going to look very similar to what we just did, but remember we changed what we're counting by. Last time we counted by half pi's, now we're counting by pi's. So this one's actually being stretched out further left and right. If I want to graph that over 2 periods, which we need to do, come over here and plop down another asymptote because that's 2 pi's away from the other asymptote. Halfway between there is a 0. Halfway between there is going to be your -1. Halfway between there is going to be your +1. The graph looks something like that. Okay. Let's look at question number 8 now. Question number 8, graph the -3 tangent of 2x. So what happens there? Let's just go ahead and list out the things again. Period is pi over b, which is pi over 2 for this one. Okay. Now the amplitude, remember that's not really amplitude anymore, but it's being stretched by 3. And what's that negative do to it? That's going to reflect it over x-axis. Okay, so our curves are normally going up. Now we're going to be going down because we're flipping it upside down. Okay. So let's go ahead and count by what we want to count by. And I'm going to say that each one of these, let's do half pi on these. So that would be 2 pi over here, and -pi over here, and -2 pi. Now I'm going to want to get 3 on my graph because the 3 is a stretch, so I'm going to add a couple of lines in here just so I don't go crazy off the graph. So that's going to be 3, and that's going to be -3. Okay. Now, what we do is Start at tangent of 0 is 0. We're not getting shifted in any which direction, so we're still going to start with 0, 0. Halfway over. Now, half of my period is a half a pi, so half of a half is a fourth. So I'm going to go over a fourth of a pi, plop down my asymptote. The asymptote looks something like that. And a fourth of a pi backwards is my other asymptote. Okay. Now I can tell from asymptote to asymptote that's a fourth and a fourth would give me a half a pi, which of course checks out right there. Okay. So halfway between those is normally at the -1, but we're stretching it to 3, so it's going to go down to 3, but then the negative flips it upside down, so it's going to go right up there. Halfway between these is normally at 1 again, but 3 stretches it, but then the negative flips it upside down. So our graph here is going to be much more compact in there together, and it's going to look something like this. And let me get my email off there. There we go. And then let's go ahead and do it over 2 periods. So we plop down another asymptote a half a pi away. Halfway between those is 0, 0. Halfway between those is going to be up here. Halfway between those is going to be down there. And there we go, like that. Okay. Now let's pull out our graphing calculator and graph these on there so we just get an idea of how that works. Okay, now I've pulled up my calculator on the screen here. I want to show you how we can graph these functions, and I'm going to show you a couple of one of the sine functions too, and cosine, just so you know how to do these on your calculator, just kind of to check to make sure everything is going good. Okay, so obviously we're going to go to y equals. Okay, if you have anything in there, clear it out. We're going to type in the function tangent of x divided by 2. There's your function. And if I go to graph right now, you're going to see that we get something like that. Okay. Now that doesn't look exactly like what the graph I have on the screen over here. It's because they're counting by ones instead of by pi's like we have over here. So if you want to match this graph up as closely as possible to the one on the calculator, we can go and change our window. So let's change our window. And on our graph right here we counted from pi to 4 pi. So I'm going to count from a -4 pi to 4 pi. Oops. There we go. What happened there? Try again. 4 pi. Delete. Enter. There we go. And I don't want to count by ones, but I want to count by pi's on this one. Okay. And my y min and max is at 1 and -1. So I'm going to type in -1 and 1. Now let's go to the graph and see if it matches up a little bit more what I have there. As you can see, it's kind of zoomed in. You know, that's what our graph is here. If I wanted to zoom that thing out some, I could see, you know, let's say I wanted to go from, not from a -1, let's say a -5 to 5. Oops. It's always great when you hit the wrong keys. Come down to a -5. I hit the minus instead of the negative. And then 5. If I go back to the graph now, I can see it's a little bit more stretched out going up and down, so you can see more of the curve going on. Okay, your calculator will not graph the asymptotes in there. Okay, it doesn't do it because it's not part of the graph. Now, if you're not getting the same thing here that I have here, make sure you go to your mode, and you want to make sure you're in radians because we're counting by radians. We're counting by pi's here, not by degrees, not by nice whole numbers, but we're counting by radians. So make sure you go to radians if you're not getting that to match up exactly. Okay. And what I want to do now is let's go back and look at example number 6, which was graphing the function of y equals 2 plus cosine of 2x. Okay, let me get my pen to work here. y is equal to 2 plus 3 cosine of 2x, just so we can make sure we understand that we can graph this also on your calculator with no problem. Okay, so just type it in, 2 plus 3 cosine of 2x, and again, you want to make sure you're in the radian mode, not degree mode. Okay, and if you look back at that example, when we did it, I counted by half pies, and we went out to 2 pi and a negative 2 pi, so that's already set for negative 2 pi and 2 pi, and my x scale is already set for counting by half pies. But on here, let's go to that'd be okay, negative 10 and 10, this should be okay. So we can just kind of see how that graph looks. And you can see the graph, it does the nice sine and cosine curves just like it does the tangent curves. Okay, so you can always check to make sure that you have these functions graphed correctly. Make sure you know they match up. Now let me show you what happens if you're in degree mode and you're wondering why your graph looks just like a line. That's why, because it doesn't do it in degree mode, it does it in radian mode only. Okay, gotta be in radian mode for these things to work. So that's just a quick, easy way to check to see if you've done it right. Okay, do not rely only on the calculator to do it, because taking it from here to your piece of paper is not always the easiest thing to do, and you can easily make a mistake. So it's important you understand how the other works. Okay, that wraps it up for section 4.6 and all the graphing of the trig functions of sine, cosine, and tangent. You should know how to be able to graph those by now.